GATE 2014 Civil Engineering Set 2 Question 44. Irrigation water is to be provided to a crop in a field to bring the moisture content of the soil from the existing 18% to the field capacity of the soil at 28%. The effective root zone of the crop is 70 cm. If the densities of the soil and water are 1.3 gram per centimeter cube and 1 gram per centimeter cube respectively, the depth of irrigation water required for irrigating the crop needs to be found in millimeters. The relevant NPTEL reference has been listed. So assuming a section of a crop field. So if this is the soil sample, there will be a certain depth up to which the plants will grow. So that is called the root depth D. And we need to supply water. So initially the water will be at a level which is called the permanent wilting point. This is the point at which the crops start to dry, and we need to take this up to a level that is called the field capacity, which is considered ideal for the growth of the crops. The zone of water difference varies between these 2 points. So the water supplied by irrigation should be equal to the density of the soil by the density of water into the depth of the roots into the field capacity minus permanent wilting point. Here field capacity and permanent wilting point are taken in units of percentage, and they are converted to decimals before putting into the equation. dr is the depth of root zone, gamma d is the density of soil, and gamma water is the density of water. So using the equation 1, we can find the required depth of irrigation for a certain root depth. So in this case, the root depth has been given as 70 centimeter. The density of soil has been given as 1.3 gram per centimeter cube. The density of water has been given as 1 gram per centimeter cube. The field capacity is mentioned as 28%, and the initial water level is given as 18%. It is not given if it is permanent wilting point, but we can assume it. So the depth of water required for irrigation would be equal to gamma dry by gamma water into depth of root into field capacity minus the initial water level. So gamma dry is 1.3, gamma water is 1 into root depth is 70 into field capacity will be taken as 0.28 and initial water level is 0.18. This would give the value as 9.1 centimeter. But the question instructs to find the value in mm, so we will operate this with 10. So that would give us the answer as 91 millimeter. So the depth of irrigation water required for irrigating the crop is 91 millimeter. The relevant NPTEL reference has been listed.